So my name's Joe Baguley. I'm the Chief Technology Officer for EMEA here at VMware. VMware, for those of you who don't know, is one of the older software companies from like the old days, apparently, where we do virtualization. Actually, we're now about 22,000 people strong, and we have strong research led in the Office of the CTO by myself and my colleagues in areas such as AI and machine learning in various different categories. But I'm here today to talk to you about a particular area, which is the edge. So if my slides do start working, I don't know if they're getting there, we can talk about that. For those of you who don't know what edge is, it's about how we're spreading back out again in networks and applications. The challenge that we have in our industry is that, in reality, networks are crap, is the biggest problem we've got when developing applications. Networks are not fast enough or wide enough for the data that is being created at the edge of our networks. And you'll hear this a lot talked about as the Internet of Things, or as I prefer to refer to it, the instrumentation of things, or the Internet of Stuff, or if you're a government, the Internet of other people's stuff. But generally, it's collecting data from sensors. And so the edge is really where physical meets digital. And that's moving closer and closer and closer to the person, the further we get through time. And as we do that, we're seeing new technologies and techniques being defined here. So am I going to be far? No, that's really not my slide either. OK, so we'll get there in a minute. So what you've got, I'm going to explain slides now, which is kind of cool. What you have to understand is, oh, that's not far off. There we go. What's the next one? It's a tiny slide. What you're looking at here really is the fact that we talk about three real areas in application design. There's now the cloud, there's the core, and the edge. And these are actually come from the world of networks. The cloud is what you all know, the Googles, the Facebooks, the Amazons, etc., where you can store and run things in huge scale at low cost. The core is what traditionally enterprises and other people have called their data centers. And the edge is now further and further and closer out to where things are happening, where they're needing more compute to happen, and more importantly, more AI and ML to happen. Now, to understand what I mean here, the networks have a problem with latency that is based on a fundamental problem, the speed of light, that we will never, ever solve. So what we need to do is move compute, AI, and processing to be closer and closer to where it's needed. The best example I can give you of this is Alexa and Philips Hue lighting. I have Philips Hue lighting and Alexa in my house. I can sit in my kitchen and say, turn off the kitchen light. Approximately 4 to 6 seconds later, my kitchen light turns off. Now that's cool, okay? Because that's still quicker than it would take for me to get up off my arse and go and flick the light switch. So I'm winning. And that's why people like it. Now I want to flip you to a different scenario, because what actually happens in that Philips Hue example is essentially you talk to Alexa, Alexa then captures what you said, takes it up to the cloud, does some voice to Dex, does some NLP on it, works out what it is, hands it to the AI engine that then goes over to Philips Hue through their API, which then comes down to the funny little Zigbee node that you've plugged into your network, and bang, your light turns off. Right, the other technology that I have in my life is a Tesla. I think there's one here somewhere downstairs. Now, that has a fantastic piece of technology called Autopilot, which seems to be the source of discussion and research driver for pretty much every AI project I'm talking to, is in image recognition for autonomous driving. Now, I can tell you right now, when that car pulls out in front of me into the gap that my autopilot nicely leaves safely to the car in front, and when that car pulls into that gap, usually an Audi, what I want is I don't want my car to wait 6 seconds whilst it talks to the cloud to work out that it needs to brake. I don't want that robot controller that's in the factory moving huge bits of machinery around to hang about for 6 seconds whilst it decides it's not going to swing itself into that human and cut them in half because they've walked where they shouldn't be. And so you can hopefully understand that what I need to do in my architecture is put more and more intelligence and more compute power closer and closer to the edge. Now, the great thing is that's actually not that hard now because of the way that we've changed the way we build applications. The way we build applications used to be that you get a big server and a big database, and you run something like Java or WebSphere or WebLogic on that, or buy something from SAP, and it all sits in a big data center. And that's where it all happens. Well, luckily, over the last 10 years, through cloud computing and other technologies, microservices, etc., we've seen a revolution now where you have a huge choice of how you build the components of an application. The answer is no longer, oh, it's just another bit of Java you have to chuck on the server. It can now be, oh, you can put that in a container and distribute it across 3 clouds. Or you can do it in a platform as a service, such as Cloud Foundry. Or you can run it as functions as a service using something like Lambda or OpenFAS. And those pieces mean that applications are stretching vertically to become more and more stratified. Why are they doing that? Because people are finding the best and most efficient place to run that component in their stack. Because, surprise, surprise, running all the components in your stack on one big server in a data center wasn't the most efficient place to do it, from both a cost and a power perspective. So as we start to stretch it out, I might find that actually I need some image recognition, and there's a really cool piece of image recognition that Azure does for me and Microsoft, so I'm going to call that into my function that I'm using. So these applications are becoming more and more distributed. So now when you're looking at application architecture, people are now fighting to say, okay, which of the 5 stacks of infrastructure, containers, platform, function, and software as a service am I going to choose from for this component? And there's multiples between that as well. And then they're choosing whether they're doing it on-premises in their data center or off-premises in someone's cloud. So now we're looking at 10, possibly more destinations that they could put this part of it. But more importantly, now they're looking at multiple locations they can do that. So I'm working with a retailer at the moment, and the retailer is trying to put some really, really clever AI into their stores that uses the feed from the CCTV that's live in the store to track where people are in the store, to work out stock levels, what people are looking at, etc., and advise around a whole bunch of different things, but potentially gain insight from looking at where people are in the store. They can't do that with centralized compute. It's just not going to happen because they haven't got the bandwidth in their stores. Some of them are on the end of bits of ADSL. They need localized storage, and they need localized compute. The problem is if I go and talk to the people who maintain that branch infrastructure and ask them and tell them I need to run 15 containers in every store, they think I'm talking about plastic boxes. They have no clue that a container is a new type of construct for compute, well, not that new anymore. So what we're looking at here, oh, my slides have appeared, fantastic, right. So what we're looking at here is we're looking at people now working out where is the best place to execute that different piece of their function and their understanding. And more importantly, not only where in the stack logically, but where in the world physically. So I'll give you another quick example as we get towards the end here. One thing to think about is telcos. Telcos are now virtualizing their networks. What used to be on top of this building, for example, or in the basement would be a cell tower, and in the basement would be a rack of infrastructure, all made very specific bits of hardware to do with running a cell tower. That's now changed. It's all based on x86, and they run all the functions in the network as virtual machines. That now means they're actually running a distributed cloud. That now means they can turn around to a betting company and say, oh, dear betting company, would you like to spin up in containers the front end of your web services for your betting platform in the radio control nodes next to every single football stadium in the UK for 4 hours every Saturday afternoon? So you're the fastest responding, best website to use for online betting. So new opportunities are opening up as edge computing expands and moves its way out, and people are looking for more and more platforms as to where to do that. So really, as we go forward, I want to leave you with a thought. As you go as application developers and think, I don't care about infrastructure, you will care about infrastructure as you develop AI more than you ever believe. You will care about where you execute your algorithms, whether it's in the cloud, through the core, all the way to the edge. You will care about having a consistent platform to do that on, and you'll care about the cost of your compute, because this wave is now starting. I'm a big driver personally around sustainability, and one of the things we're looking at VMware is we're now penalizing developers for, or looking to penalize developers, for wasteful code. Think about it, right? Every time I go to compile, if I waste another 10 compute cycles to compile, how much does that add up to over time in terms of cost to the planet? And when we've got something like Bitcoin, there's the blockchain theater somewhere else over here, that currently annually uses more electricity than Switzerland to run Bitcoin, I encourage you as we head into this next great brave frontier of AI to think more intelligently about the sustainability of the code, the sustainability of your architecture, and understand that you need to think not only vertically, logically about where your AI sits in the stack and your code, but also physically, where is the best and most efficient place for that to sit. So Thank you very much.
Fantastic, Joe, and you really handled the technical challenges. You didn't need slides. But is it true to say then it's going to get more complicated before it gets less complicated?
Very much so. I think people seem to think that it's all about, oh, I want to play with AI, I'm going to go and connect to DeepMind and code some stuff up. And there's no doubt that the winner of the cloud wars will be the one that has the easiest to use AI platform for enterprises. But I think now developers need to talk more to infrastructure people, hence the DevOps world that you hear about. As I say, it starts to spread itself out from that one thing in one data center.
Well, I'm so sorry you can't stay for our panel. You've got a very important meeting somewhere, so you've got to dash.
But, great. Thank you for having me.
Thank you.
Cheers.
See you again.